All right, welcome back. Let's get started on example 2, transformation sequence and similarity. So with this problem, we're going to identify the combined transformations from the original to the final image and tell whether the two figures are similar or congruent. So we have ABC, triangle ABC here, A prime, B prime, C prime. Let me go ahead and make that a little darker. ABC, then we have A prime, B prime, C prime, and then we have a double prime up here, B double prime, and C double prime. So first we need to figure out what's going on from here to here. What do you think? Dilation, translation, reflection, rotation. To me, this looks like A is on top here, A is on top, B is on the bottom, B is on the bottom, bottom left, bottom right. They're all kind of in the same position, so this looks like a slide of translation. So let's go ahead and see if we can figure out that rule. We start here. It looks like we go over 1, 2, 3, up 1. Okay, let's see if that's the same for each one. So that would be, I'm going to see if I can move this up and write down here. So looks like from triangle ABC to triangle A prime, B prime, C prime, there is a translation. XY goes to this, what did I say? X over, what do you think? 1, 2, 3. So that would in the positive, so X plus 3. And Y goes up 1, so Y plus 1. All right, so let's see if that's true for all the points. We see that that's true for A. 1, 2, 3, up 1. How about B? 1, 2, 3, up 1. Okay, that works. And C. 1, 2, 3, up 1. Perfect. Okay. Now let's talk about from A prime, B prime, C prime to A double prime, B double prime, C double prime. What's going on? What do you think? To me, it's very clear that this sucker is getting bigger, right? And the only one where something gets bigger is a dilation. So let's go ahead and look at these coordinates. So let's label them. So A prime is -1, 3. B prime is -1, 2. C prime is 1, 2. Okay? And yes. So over here, I'm just going to do some work. And I'm going to first evaluate A prime and A double prime and see if we can come up with a pattern. So A double prime is -2 and up 4, 5, 6. Okay. So we have here. So how do we get from -1 to 2? Or how do we get from 3 to 6? I would say from 3 to 6, it looks like we're multiplying by 2, right? 3 times 2 is 6, and -1 times 2 is -2, so that works, all right? So it looks as if the transformation that's happening is that from triangle A prime, B prime, C prime, that is going to A double prime, B double prime, C double prime through a dilation of XY going to, we're multiplying the X part by 2 and the Y part by 2. Okay, so let's just see if that's true. So what happens for B? So right now B is -1, 2, right? And this is B prime. And we're going to B double prime. So let me put that rule up top. For the dilation, they both get multiplied by 2. So we go -2 times 2, which would be -2, and 2 times 2, which would be 4. So let's see if that's the point for B double prime. Is it -2, 4? So -2, 1, 2, 3, 4. Hey, that's right. Perfect. Okay, so we know it works from there. The last one we have to determine is C prime. So C prime is 1, 2, and we're trying to go to C double prime, which would be 1 times 2, which would be 2, and 2 times 2, which would be 4. So is that the case for C double prime? 1, 2, yes, and up 1, 2, 3, 4. Perfect. Okay, So that works. So we have the first thing we have from triangle ABC to this triangle, we have a translation, and then from a translation, we have a dilation here. So we just need to tell whether the two figures are similar or congruent from the original to the final. And so what I'm going to say is that triangle ABC is similar, right? Because these have the same shape, but they do not have the same size. So that is similarity, not congruence. So triangle ABC is similar to triangle A double prime, B double prime, C double prime. All right. Okay, and that's how you show your work and solve this problem. Okay, let's go ahead and look at this next problem here. And for this one, I want you to try to do this one on your own. Okay, so this is B. And, okay, I think I got it all in the same frame. Perfect. Okay, here is my friend, the pause dragon. You know what? Before we do this, I'm going to make this a little darker. So this is A, B, C. This is A prime, B prime, C prime, and this is A double prime, B double prime, C double prime. Okay, now we're ready for my friend, the pause dragon. Remind you to pause your device. Go ahead and work this problem out. When you get done, press play, and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So, all right, I'm going to move this up. So the directions: identify the combined transformations from the original to the final image and tell whether the two figures are similar or congruent. Okie doke. So we start here and we go here. If you look here, this is pointing up, right? And now it's pointing through to the right. So this is definitely looks like a rotation, right? It's just in a different orientation than right here. So let's try to figure out. So whenever I think it might be a rotation, I like to go ahead and draw lines to the origin. So from A to the origin here, and from A prime, I mean, it's just pretty obvious. I mean, this is 90 degrees, right? And then which way is it going? It's going this way, which would be a clockwise rotation. So this looks like a 90-degree clockwise rotation. So I'm going to say triangle ABC goes to triangle A prime, B prime, C prime by a 90-degree clockwise rotation about the origin. And then I'm just going to put that rule, right, which is X, Y goes to, and I know with rotations, it's always this, right, YX, but sometimes I forget which one's the positive and which one's the negative. So to remind myself, I'm going to take A, and I'm going to say what this point is. This is negative 3, 0, and I'm going to double check because I messed up this the last time. Okay, so negative 3, 0. And then this one is A prime is 0, positive 3. Okay, so my X here is moving here, but it's negative and now it's positive. So that tells me that it's going to be the negative X. And then here, my Y is here, and it's the same. So, okay, so that's my rule. So now I'm just going to check my rule with all the other vertices to make sure that everything else works. So it works for A and A prime, but I always want to double check with B and B prime and C prime. Okay, so I'm just going to kind of work right here so it can all be in the right screen. So I have A and A prime. So now I'm going to go to B, which is negative 5, 0. And I want to go to B prime, and I'm going to write the rule. So the rule is X, Y goes to Y negative X. Okay, so that means that my Y is first, and then my X becomes negative, and this is already a negative, so a negative times a negative would be a positive. So is B prime 0, 5, 0, 5, and it is. Okay, perfect, so that one works. Now I'm going to try C. And C is, I'll just go ahead and write what this is. Okay, C is negative 5, 3. And that's going to go to C prime, where the y is the same. So the y is first now, 3, but the x becomes negative. This is a negative, so negative times a negative is a positive, so it should be positive 5. So is C prime 3, 5? 1, 2, 3, and up 5 it is. Okay, so that means that it is indeed a 90-degree clockwise rotation about the origin. Okay, perfect. So now we just need to determine from A prime to B prime to C prime what happens with A double prime, B double prime, C double prime. Well, it looks a little obvious, the fact that it's getting bigger, so we just know it's a dilation, right? Or we have a good idea. So what I want to do is, but I need to figure out that scale factor, right? So let's go ahead and come up with the point A double prime. This is 0, 6. And so what I want to do is I want to compare A prime with A double prime. And so 0 to 0, that doesn't really help. Okay, 3 to 6, what's happening? 3 times 2. So it looks like we're multiplying it by 2, right? So that would be the rule xy goes to 2x and 2y. Okay, so let's go ahead and see if that works for the other vertices, B and C, or B double prime and C double prime. So I already have written down here that B prime is 0, 5. So now I'm just going to go and I'm going to do one more to B double prime, multiply this by 2, 2 times 0 is 0, and then 5 times 2 would be 10. So is B double prime 0, 10? 0, 10 it is. So that means that one is a dilation with a scale factor 2. And so then we're just going to check C double prime. So we have C here, which is 3, 5. And then we're going to go to C double prime. So we multiply 3 times 2, which would be 6. And we multiply 5 times 2, which would be 10. And we end up with 6 and all the way up at 10, and it is. So that's perfect. So this is a dilation with scale factor 2. So what we can say is that the second thing is that triangle A prime, B prime, C prime goes to triangle A double prime, B double prime, C double prime by a dilation, and then we're going to write the rule. xy goes to 2x, 2y with a scale factor of 2. And then the last thing, it says tell whether the figures are similar or congruent. From here to here, there's definitely a change in size. The shape is the same, but the size is different. So we can say that those two triangles are similar. All right, and that's our answer. So please make sure that you have all of this on your paper. If you got this one right, great job. I'm super proud of you. If you don't, or you made a little error, that's fine. Just go ahead and erase and make sure that your work matches up with mine. All right, that's it for this example, and I'll see you in a little bit for example 3.